Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Yusuf, and my group and I will present chapter 24 electronics. So, operational amplifier introduction. Operational amplifier is a differential amplifier which has high gains, composed of a large number of transistors and resistors assembled together in the form of integrated circuit. Amplifier can be used as inverting amplifier, non-inverting amplifier, voltage amplifier, integrator, and oscillator. So that is the picture or image of the external view of one such packaged chip. Next one is symbol for operational amplifiers and connections. So the image show the symbol of the operational amplifiers, and the connections is operational amplifier has several terminals to connect the amplifier to the external component. The first one is two input terminals. V1 is applied to an input of the non-inverting amplifier marked with a positive sign, and V2 is vice versa to V1, which is inverting amplifier and marked with negative sign. The next one is an output terminal. The resultant voltage appears as an output voltage. VO. Next one is two terminals for external power supply, one terminal for positive supply voltage and one for negative. The next one is supply voltage. Uh, the uh, the operational amplifier circuit above is in the open loop mode because the two inputs are not connected via circuit component or network to the output. Next one is characteristics of an operational amplifier. The voltage gain is infinite, and voltage applied to the inputs would produce saturation voltage at the output, infinite input impedance, zero output impedance, and infinite bandwidth. Next one, characteristics of a practical operational amplifier. The voltage gain is high, which is in range 10 to the power of 3 to 10 to the power of 6 at low frequencies. At high frequencies, gain is lower. Input impedance is high, in the range of 0.3 mega ohm to 2 mega ohm. The output impedance is low. Bandwidth is narrow, low as 10 Hz. Operational amplifier as a differential amplifier. So from the figure, amplifies the difference VD between the electric potential V1 at the positive input and the V2 at the negative input. The amplified voltage appears as the output voltage VO. VO is greater than VD in the open loop mode. Next one is open loop voltage gain. V1 applied at positive input relative to earth. V2 applied at negative input relative to earth. Non-inverting is for positive, inverting is for negative. The formula is VD equals to V1 minus V2. Next one, the potential difference is amplified by the operational amplifier. The output voltage VO will be voltage output equals to open loop voltage times to VD. Open loop voltage, known as the open loop voltage gain of the amplifier, value is high, which is in range 10 to the power of 5 to 10 to the power of 8 given unit decibel. Next one is sign of the output voltage. Sign of the voltage output. Output voltage is determined by the sign of VD. If V1 at positive input is more positive than V2 at negative input, then VD and output voltage are positive. If V1 is less positive than V2, then output voltage are negative. Saturation of output voltage. Definition: saturation voltage is the maximum voltage of output voltage. When VD increase, output voltage will also increase continuously until reaching certain value and will not increase anymore. The values of saturation voltage, the supply voltage which is applied to the amplifier determines the value of the saturation. For example, voltage saturation is 0.9. So the supply voltage is given 15. So the voltage saturation will be 14, which we get from 0.9 times to 15. Next one, saturation of output voltage, order of magnitude of VD to produce voltage saturation in open loop mode. So this is the range that we get. So the important one is VD is less than a fraction of a millivolt, meaning that voltage output easily gets saturated when VD is less than millivolt. The next one. So this is the graph of voltage output against VD for operational amplifier in open loop mode. So the first graph is at the left one is the axis that VD we axis microvolt, and the right one is VD we axis millivolt. So there is the difference between them. Next one is magnitude of input currents and VD. Magnitude of the two input currents, the impedance from the figure, the impedance of each input is high because of these currents I1 and I2 which flow into or out are extremely small. From the figure we can see that we can assume that I1 and I2 is we can assume that they are zero. The next one, magnitude of VD. The differential voltage VD across the two inputs is small. That is why we assume VD equals to 0 for an ideal operational amplifier. Next one, instability of open loop voltage. Open loop again is not easy to keep constant its value. Increase in temperature of circuit components and the operational amplifier itself can change the value of the voltage open loop. In open loop mode, amplifier has a narrow bandwidth. If the amplifier operates beyond this narrow, the gain drops very fast. So that's all from me. My other member will present the other subtopic. Thank you.
Next, I will explain more about inverting amplifier. An inverting amplifier is an operational amplifier circuit with an output voltage that changes in the opposite direction as the input voltage. In other words, it is out of phase by 180 degrees. It is important to note that the characteristic of inverting amplifier is no current flows into the input terminals, and the differential input voltage is 0 as V1 is equal to V2 is equal to 0. Here is the example of OP amplifier. The negative signal is the inverted input while the positive signal is the non-inverted input. If we apply a signal to the negative, which is inverted input, the output will be inverted, which is 180 degree out of phase. While if you apply a signal to the non-inverted input, the output will be non-inverted and the same as the input. Here is the circuit diagram for inverting amplifier. The signal is applied to inverted input, which is negative sign, so the output will have inverted signal. RF is known as feedback resistor. This resistor takes some of output signal and feeds it back to the input. So as a result, it will reduce voltage gain. To calculate voltage gain, V output is divided by V input. When you have a feedback resistor, the voltage gain is said to be a closed loop voltage gain, and that gain is also equal to negative of RF divided by R input, which is input resistor. If we get rid of RF, feedback resistor will not be in closed loop mode. Instead, it will be open loop mode. On the other hand, a non-inverting amplifier is an operational amplifier circuit with an output voltage that is in phase with the input voltage. For non-inverting amplifier circuit, input signal was applied to the positive terminal because it is a non-inverting amplifier. So the output signal will be the same phase of input signal. Feedback resistor was also the same like the inverting amplifier. It is between negative terminal to the output. To calculate closed loop voltage for non-inverting amplifier is the same equation as the inverting amplifier, but there is no negative here and also have the addition of 1.
Hi, Assalamualaikum. I am Adilah. So now I will present about the voltage comparator. So what is voltage comparator? A voltage comparator compares two voltages applied to the two inputs of the op-amp. The outcome of the output voltage will reveal the relationship between the two voltages. One applied voltage may be kept constant at certain value and used as a reference by the other applied voltage, and the reference value may be 0. So this is the circuit of voltage comparator. The op-amp is connected in the open loop mode, hence there is no feedback. A voltage is applied to each input. However, we may have one of the inputs earth. Normally, one voltage is kept constant and serve as a reference voltage. And from the figure, we can see that reference voltage may be applied to the negative input or the positive input, and a signal voltage is applied to the other input. Next, the principle of voltage comparator. The op-amp works in the open loop mode, hence it has an extremely high open loop gain. Because of this, even a very small difference in the two input voltage will drive the output voltage to saturation. And when the signal voltage is greater than reference voltage, the output voltage becomes saturated and is, say, positive. And conversely, when input voltage is less than reference voltage, the output voltage also becomes saturated, but it is now negative. Hence, the polarity of the output voltage will indicate whether the signal voltage is greater than or less than a reference voltage. Next, integrator. So what is the main function of integrator? An integrator produces an output voltage which is proportional to the time integral of the input signal voltage. So this is the graph of the integrator, and if the input voltage is a square wave, the integrator will convert it into a triangular wave. So this is op-amp integrator circuit. The resistor and capacitor form an RC circuit. When the signal voltage varies, a charging or discharging current will flow in this circuit, and this integrator circuit will convert a square wave into a triangular wave. So what is the principle of integrated circuit? Firstly, we suppose that the input voltage is a square wave. Within one period of time, this voltage could be a constant positive voltage. Because the input signal is connected to the negative input, the output voltage is negative, opposite to the polarity of the input voltage. The capacitor now is discharged. Within the next period, the input voltage changes polarity and becomes a constant negative voltage. During this period, the capacitor will charge. As the input signal of square voltage alternates its polarity regularly, keeping its magnitude constant, the capacitor undergoes a process of charging and discharging. And if the time constant RC is suitably chosen, the rate of charging or discharging could be carried out at a constant rate, thus producing a triangular output voltage. Next, oscillator. So what is the main function of oscillator? An oscillator generates an alternating current and voltage of a predetermined frequency with no external signal source applied to the input. The waveform of the output could be a sine wave, square wave, or triangular wave, and an oscillator has a DC power source. The oscillator actually converts energy of the DC power supply into energy carried by the alternating current generated by the oscillator. So this figure shows the circuit for the basic op-amp oscillator. So notice that there is a positive feedback and frequency selection network connecting the output to the input, and there is no external signal connected to the input. The signal which the amplifier does receive is that fed back from the output. And a DC power source, which is not shown in this figure, is connected to the amplifier. And lastly, essential requirements for oscillation. In order to achieve oscillation and sustain it in a stable condition, the following requirements must be met. The first one, there must be an amplifier. Second, there must be a selection network to select a signal at a given frequency from the output. Third, there must be a positive feedback network to send the desired signal from the output to the input. And lastly, the following criterion must be satisfied, which is BA equals to 1. That's all from us. Thank you so much.